Okay, so here we have Ed and Adelaide. They attend the same high school, but they're in different math classes. And it says that the time that it takes Ed to do his math homework, represented by E, follows a normal distribution with a mean of 25 minutes and a standard deviation of 5 minutes. Adelaide's math homework time, represented by A, also follows a normal distribution with a mean of 50 minutes and standard deviation of 10 minutes. We're going to assume that E and A are independent random variables. Okay, so part A tells us to randomly select one math assignment of Ed's and one math assignment of Adelaide's. Let the random variable D be the difference in the amount of time each student spent on their assignments. D is going to then equal A minus E. We want to find the mean and the standard deviation of D, for the difference D. Okay, so it's kind of a lot, it may seem, but let's just break this down. So let's look at first Ed's distribution. So Ed's distribution is normal. With the mean, and we're gonna we'll just put mu sub E for Ed. The mean of Ed's homework distribution is 25 minutes, and a standard deviation, so sigma sub E will be 5. And for Adelaide, she has a mean of 50 minutes, so we'll use mu sub A. And the mean is 50, and her standard deviation, sigma sub A, will be 10. Now we're looking at the distribution of the difference in the amount of time between Adelaide minus Ed, where the difference will be A minus E. So we're looking for the mean of D. So the mean of D, since we're looking at sum or difference of random variables, the mean of D will be the mean of A minus the mean of E. So the mean of A minus the mean of E. And that'll just be 20, or that'll be 50 minus 25. It'll just be 25. Now the standard deviation of D, you can't simply add the standard deviations of A and E to get the standard deviation of D, because standard deviations don't add. However, variances add. So we can find the variance of D, which is the standard deviation squared. We can find the variance of D by adding the variance of A to the variance of E, because variances add. Once we find the variance of D, we just take the square root of the variance of D, because the square root of the variance of D is the standard deviation of D. So let me just jump ahead to show you what I mean in case you're a little confused. Going back to algebra, square root of anything squared will give you the standard deviation. So if we find this, then we take the square root of it, and we'll get the standard deviation. So the standard deviation, or the variance of Adelaide, will just be her standard deviation squared. So 10 squared. And the variance of Ed, or his standard deviation squared, will just be 5 squared. So this will just be 125. So we're taking essentially the square roots of 125. We're most likely going to get a decimal approximation, which would be about 11.18. Okay, so we got part A. Now in part B, we have to find the probability that Ed spent longer on his assignment than Adelaide did on hers. So if Ed spent longer on his assignment than Adelaide, that means if you have A minus E as a difference, that means that E needs to be greater than A, because obviously that means that E is spending more time, or Ed is spending more time. So if E is greater than A, that means D has to be a negative number. So we want to find the probability that D is less than 0. If you find the probability D is less than 0, is saying that E has to be more than A, because that'll be a negative number. That means that Ed is greater than Adelaide's time. So let's just draw a little sketch of what's going on here, because this is always easier to explain. I love having pictures to back up what's going on. Remember, we have a normal distribution of D with a mean of 25. So this will be the middle, mean of 25, standard deviation of 11.18. And if we want to find the probability that D is less than 0, we're looking somewhere, over here to the left. We're looking at an area. It's probably going to be small because it's going to be more than 2 standard deviations away from the mean. So we're looking for this small area. So we're looking from the area from essentially like negative infinity, hypothetically speaking, all the way to the left. As far left, the lower bound will be negative infinity, the upper bound will be 0. So we can just then use this as our normal distribution calculation in our calculator. So once you become competent and understand the z-scores and everything, I'll show my students how to do it quickly in their calculator. You can go to distribution, go to vars, and then distribution, and then go to normal CDF. And here you're going to have the lower bound, upper bound, mean, standard deviation right away. And so what I'm doing here is normal CDF. I have my lower bound is all the way the farthest number to the left. So I'm going from like negative, we'll just say like negative. We have to enter some number. We can't enter negative infinity, but we'll just say like negative 10,000, followed by the upper bound. So upper bound will be 0, or the right side. And the mean of the distribution will be 25. The standard deviation of distribution would be 11.18. Oops, 11.18. You enter the syntax like this, and your calculator will give you the probability just like that. Now, depending on how your how old or what brand you have, what version you have, may be a little easier to figure it out. But here, this is the old school one, so you have to memorize the syntax. So we go lower bound, so negative. Let's say like negative 10,000, comma, upper bound 0, comma, mean 25, standard deviation 11.18. So lower, upper, mean, standard deviation. Again, if you have a newer version, you'll probably have it's just explicitly say lower bound, upper bound, mean, standard deviation, so it'll be easier to use. Anyways, in either case, you'll get about a probability of 1.267%. Point 1267. So again, since this is show your work, make sure you do show your work on an actual test. If this is like a free response problem, you'll be graded not only on the work, but also, how you present your answer. So write something like, there's about a 1.267% chance that Ed will spend longer on his homework assignment than Adelaide will on hers.